Okay, the whole chapter's been about what? This linear equations, right? Okay, so this is section 3.2, zeros of a linear function. Algebra 1, we're on page 151. Okay, the whole, so far we've talked about lines, haven't we? That's been the whole gist of this, isn't it? We've had lines, and we talked about that lines could be in different forms, and the first form that we talked about was standard form. Standard form, okay, and that was capital AX plus capital BY equals C. And that was the tuxedo form, right? That was the form that said, hey, well, we look nice, right? Okay. We actually talked about two other forms. Was the slope-intercept form, right? Which we're going to dwell in the next section. We're going to dwell more on that. And then we talked about the point-slope form. And the point-slope form was the guy that did all the work and got no credit whatsoever, right? Which form was that, Braxton?
Point-slope form.
Point-slope form. Got it? All right, Jackson, you got it?
Yep.
So those are the three forms. But right now we've mainly stuck with this. Today they're going to, it says zeros of a linear function. Okay, well first of all we need to talk about a linear function. Well, it has the word linear in it, so it's probably a line, right? So what I'm going to teach you today is we're going to write f of x is a fancy way to write y. So we're going to replace y with f of x, and this is called a function. Okay? Now, a function is another way of naming equations, but functions are special. For every x value, there's only one y value, exactly one. So what we're going to have is something that looks like this. F of x equals x. Now, this is kind of confusing for students. They look at this and they go, wait a minute. This takes the place of y, okay? And this is y equals x. Guys, if you look at y equals x on a graph, and I'm not going to use a coordinate plane, but it goes through 0, 0, it goes through 1, 1, goes through 2, 2, and so what it looks like is this line right here. It looks like that. This line is what we call a parent graph. All other lines are going to be based on this, we're going to move it. This is our parent graph. Okay? So all other lines are going to look like this. Now, remember what I call the line that is not vertical or horizontal? What did I call a line that is not vertical or horizontal? Oblique. This is the beginning of oblique lines. Okay, and they are all based on this line. Oblique lines, the domain is this and this. Do you remember that? And the range is this and this. That means from a negative infinity to infinity, oblique lines are like that. All right? Now we have the two, let's remind ourselves, what are the two bad boys? Horizontal and vertical. They do not fit this pattern. Okay? The vertical line is x equals some number, and the horizontal line is y equals some number. Okay? They do not fit this oblique line pattern. Okay? All right. So what we're going to do is I'm going to switch gears here. We're going to go to a graph. Now you can use your graph or however, but we're going to look at linear functions, and I'm going to show you one. I'm just going to create one right now. I'm going to put y equals x minus 2. Y equals x minus 2. And I'm going to show you how to graph these. And this could help you too, Braxton, on today's assignment. Okay? I'm going to show you, I'm going to replace now the y with f of x equals x minus 2. I wanted to show you both of them. This is called a linear equation. It's actually in slope-intercept form. And this is called a linear function. The only difference between the two, Charlie, is I put f of x and I replace y with f of x. So f of x is a fancy way to write y. Do you understand that? It says, okay, this is a function, I'm going to put numbers in for x. All right. Whenever you have something like this, you see this guy right here? This tells you where it's going to touch the y-axis. This tells you where it's going to touch the y-axis. Tater, it's going to touch the y-axis at a -2. So I already have a point. Now I showed you that, and I've not shown that in the past, but that's a shortcut. Okay? So if you ask me, well, I can't get any points, I'm going to look at you and say, well, you should get one. That tells you where it touches the y-axis. By the way, if it touches the y-axis, what's it called? Y-intercept. Who said that? Thank you. Y-intercept. It's called a y-intercept. Okay. So we need another point, right? All right. So let's go ahead and find another point. All right. So I'm going to use the t-table. That's how I find another point. And I can put, if I put 0 in for x, I get 0 minus x is -2, right? All right. So can I put 1 in for x? Can I put 2 in for x? Can I put 3 in for x? I can put anything I want in for x. Let me show you. I'm going to put 4 in. Why? Because I like 4. So I get, now when I do this, I'm going to change it back to y so you understand that it's an x and y chart. And y is replacing f of x. Do you understand that? Y is replacing f of x because it's what I'm used to. So now I have 4 minus 2, correct? Y equals 4 minus 2. Y equals 2. So what's my new point? What's my new point? What's my new point? What's my new point? Thank you, Tyra. It is 4, 2. A point requires two numbers, an x and a y, on the coordinate plane. Do you understand that, Jackson? Yes. Okay, so I already got this point, right, Jackson? Now I'm going to graph 1, 2, 3, 4, 1, 2. Do you see that, Jackson? Do I have 2 points? Yes. All right, so what I'm going to do is I'm going to draw this line in. All right? Does everybody understand that? Where'd the first point come from? The first number, the back of the number, right? Plus a -2, right? All right, I didn't ever change it to plus a -2. Did that freak anybody out? Should I have changed this to plus a -2? That's how I got a -2. All right. Everybody see my line? All right. See this point right here? That point right there. He is very important. This is called a zero of the function. He's called a zero of the function. He's also called a solution of the function. He's also called a root of the function. He's so important, we give him 3 different names. He can be called a solution, he can be called a zero, and he can be called a root. What was the name of this section again? Zeros of the of functions, right? So this is really what we're going today. This is the whole gist of it. All right? What is the coordinates of that point? Jackson.
0, 2.
Try again, Jackson.
2, 0.
Thank you. 2, 0 is a zero of the function. That is the answer to the zero of the function. Does that make sense to you? Yes, dear.
So that's what y equals?
No. That is where this line touches the x-axis. All lines, the zeros of the functions, are where the line touches the x-axis. Let me say that again. All zeros of a line are where it, of any graph is where it touches the x-axis. Yes, sir.
So y, is there a 0 of the y?
Yes. Oh, yeah, right here. But it's not called a zero of the function. It's called the y-intercept. This is called the x-intercept, but it's also called the zero of the function. Okay? All right? It makes the function 0. That's why it's called a zero of the function. It's also called a solution or a root. Okay? Tyra, will you do me a favor before we do the next one? Would you try to shut the 6th grade door and our door, please? Okay, you see how to do that? So that's how we solve for a 0 by graphing. That's how we solve for 0 by graphing. Okay? Does everybody understand that? All right, we're going to do another one because you might not understand that. Okay, let me give you a new function. F of x equals 3x plus 3. All right? Okay, so we want to solve where it touches the x-axis by graphing. All right? So we already know where one point is. Taylor, if you were listening early, what is one point?
3.
This one right here. That's where we touch the y-axis. So it goes up to 3. It doesn't tell us where it touches the x-axis. Is everybody okay with that? All right. So now we need another point. You can put a value in for x or y, but I would put what in? I don't want to put 0 in for x because I'll get 3. What would I do?
1.
All right, you want to put 1 in? We'll put 1 in for x. So we have 3 times 1 plus 3. Is that correct? All right. That's 3 plus 3, which is 6. So I have the point 1, 6. All right, let's do that. 1, here's 1. Here's 1, 2, 3, 4, 5, 6. You got it? Does everybody see? Now I have 2 points. Now, it's very important that you use your straight edge really well, because you're going to find out where it touches the x-axis. Okay? Where is the 0 of the function? Where does it touch the x-axis?
-1.
-1. So it is a -1, 0 right here. That's the point that touches the x-axis. Okay? Okay. Let me ask, this is graphically, right? This is how we do it graphically. Your first set of directions is going to say find it graphically. All right? But can I tell you something? Not always going to be this easy graphically. And I'll give you an example in a minute. So what if I gave you another way that you could check it to make sure what the answer is? That'd be pretty cool, right? All right. Charlie, what is the y value here of this point? That's the x value, Charlie. What is the y value? 0. So any time that the y value is 0, you know it's going to touch the x, right? Right? So why not in my t-tail? Remember our t-tail? Why don't I put 0 in for y? And watch this. Now we don't have a y, so what is it going for? F of x. F of x is a fancy way of writing y. So I have 0 equals 3x plus 3. Now I just solve. I subtract 3 from both sides. I get a -3 equals 3x. And now I divide by 3. And I get x equals a -1. Is that what I got? All right, so there's a new method for finding a 0 of the function. What's the advantage of this? I'm going to show you. Let's erase. F of x equals 3x plus 5. All right. Let's go ahead and try to solve it graphically, right? So we go up 5, 1, 2, 3, 4, 5. Does everybody know where that comes from? Right? And then I'm going to put in, what do you want to put in? What if I put in a -1? I'm going to put a negative 1. I'm going to put a negative number in. So I have 3 times a -1 plus 5, which is a -3 plus 5. What is a -3 plus 5? 2. So I have the point -1, 2. Does everybody see that? So -1, 2. Right? I have my 2 points. Is there any questions that far? Ask me if you have questions. All right, now watch what happens when I grab this line, when I graph this line. Looky there. That's the 0 of the function, isn't it? What's the problem?
It's not on a dot.
It's not on a line, is it? So we really don't know what the value of it is, do we? So it's nice to have a second method. And what did I do again?
There's 0 for y.
Or f of x in this case, right?
Yeah.
So I put 0 in, and on this side I put 0 equals 3x plus 5. I subtract 5 from both sides, right?
Mhm.
And I taught you the other day that when you move it to the other side, it becomes the opposite sign, right? Remember that? I'm
Yeah.
trying to give you these shortcuts. It's a -5, and now we're going to divide by 3, correct? So I get x equals a -5/3. That point right there, my fast food friends, is a -1 2/3. So it is a -1 2/3, 0, or a -5/3. I will accept either one. Yes, sir.
And you said don't do decimals?
No, I want you to do, because that you would write a -1 and what? -1 point.
6 repeating.
Okay. I prefer to use fractions, and I'll tell you why. Because slope, we're going to do fractions. I don't want you to get used to doing decimals, because slope is rise over run. It's a fraction. Okay, I'm not doing it to be mean. Okay, bless you. All right, any questions about this? All right, well, I told you there are 2 lines that mess with us. They are which kind of lines? Vertical and horizontal. And we're going to talk about horizontal today. Horizontal lines look like this. Y equals 3. But what did we replace y with today? F of x. So they're going to look like this. F of x equals 3. So Braxton, they're going to look like this. If I graph this, I just go up 3 and do that. You see what I'm saying? Now, where does it touch the x-axis at, Tirsa? Louder, please. Where does it touch the x-axis? Braxton.
It doesn't.
It doesn't. No solution. So anytime that you have f of x equals some number, your answer is no solution. It doesn't touch the x-axis. Okay?
Is there ever an f of x equals 0?
Yes. It will touch the x-axis at 0. Is that what you mean?
Yeah.
Yes. Like if I have f of x, like one of your problems is f of x equals a -15x. This one touches the x-axis at 0. Okay? Vertical lines will never be in the form f of x equals, because they're not functions. So we will not discuss any vertical lines today. That's kind of nice, isn't it? Is that what you mean, Jackson?
Well, if you had f of x equals 0, and
F of x-
your line was right here, right on the
Yeah, it would
x-axis.
be all solutions. That is a great question, Jackson. He said, what if you have f of x equals 0? That is all solutions, all real numbers. So my answer would be a -infinity to infinity. That's a great question, Jackson. Excellent.
So is that the only one that would
Yes.
be,
Of functions, yes.
okay.
Yep. That would be the only one. Did you hear that? Jackson's asking some great questions. You might want to listen to him. Okay, all right. So let's take a look on page 154, please. 154. Page 154. Would you read the directions of 10 through 21 for me, Tater?
Find the 0 of each function by graphing.
What kind of method do I use? By graphing. By graphing. Now, there are a couple that end up like the last one I just showed you, in between 2 lines. And so you have to go back and use algebra to find out what the answer is. Okay, one of those is number 15. It says f of x equals 7x plus 10. Got it? So what do I graph first? What do I graph first, Tyra?
10.
10. This is 5. I think this is 10 all the way up there. Do you see y, Braxton?
Oh, yeah.
Is it 7x plus 10?
Yeah.
All right, so now I'm going to use a negative number. Why would I use a negative? Does anybody understand why I would use a negative number? Because we normally don't use negative numbers in the past. Why would I use it in this case? What does it do to the 7? What?
Makes it a negative.
Why was that important? What do I get when I take a negative 7 plus 10?
3. You get small.
You get a smaller value than 10. Do you want a larger value than 10? It's not very fun to graph, is it? You see why I'm using the negative? Okay, so I get a negative 1, 3. All right, watch what happens here, guys. Watch what happens. Where's the 0? It's right there, isn't it? It's between two lines, isn't it? Yuck. So what do? I've already showed you this twice. What do? I put 0 in for y. So I have 0 equals 7x plus 10. This is supposed to be a 10. And then I move the 10 over by subtracting it. I taught you yesterday, you can make it the opposite of what it was, right? And now I'm going to divide by 7, and I get what? Equals a negative 10 sevenths. This point is a negative 10 sevenths, which is negative 1 and 3 sevenths. 0. Now I use, this is what I call algebra. This is what I call the algebra method. Now would you take a look on page 154, 24 through 32? Would you read the directions? Jackson, what does it say?
Find the 0 of each function.
Does it say by graphing?
No.
No, it does not say by graphing.
So
So I would use algebra. I would, on flip 24, I'd move the 8 to the other side, and I would divide by 4.
you still just use the same method just without graphing.
Yes, I use this T-table method though. You already know 1 point, what is it? I mean 8, but guys, you don't even have to graph 8 on number 24. You just move the 8 over. Are you following me, Braxton?
Kind of, yeah.
Yeah, no, it kind of don't work. I don't think you're following me. I'm telling you. Watch this. 24. Look, I got rid of my graph, didn't I? No more graph, right? 24. F of x equals 4x plus 8, right? I don't want to graph it. Put y in, excuse me, put 0 in for y, remember? We put 0 in for y, and then we subtract 8 from both sides, and I get 4x equals a negative 8, and I divide by 4, and I get x equals negative 2. My 0 is a negative 2, 0, and I did not have to graph it. Now, I had a student a couple years ago say, can we do that on all of them? Can you do it on all of them? You can, but the first 10 through 21 says solve by graphing. So you can check your answers, but all your answers have to be graphed. Okay? But you don't have to on these. All right, let's take a look at the story problems. There's a couple story problems there. Would you please look at number 22 with me, please? Mr. Lords, would you read number 22 for me?
Sean budgets $160 a month to cover school lunches and any additional dining expenses. The function y equals 160 minus 4x represents the amount of money m remaining after spending $4 on
cross out, find the domain and range with a pencil, please. Lightly cross it out. Do not do that. Do not find the domain and range. With a pencil. It's the only time I allow you to write your book, when I have you cross out something, usually. Okay, with a pencil, lightly. Okay? Here's your equation. Y equals 160 minus 4x, correct? How do we know when he runs out of money? That's what it said. Represents the remaining after spending $4. Find the zero of the function. How do we find the zero of the function? How have we always found the zero? We use graphing or algebra. Which would you use on this?
Algebra.
I would use algebra. Can you tell me why?
Because you don't want to graph 160.
You don't want to graph 160. So I would use algebra. So when we find the zero of the function, how do I do that? I've just showed you 3 times now. Somebody should be able to tell me. 0 in for y. I'm going to change it to plus a negative 44x, not 40, 4x. I'm going to subtract what from both sides? 160. I'm going to divide what from both sides? Okay, and x equals? I think it's positive 40.
Oh, yeah, it is.
Alrighty. Now what does that mean?
40, 0.
40, 0. But what does it mean in this problem? What does it mean in this problem? Stands for something. 40 meals. What happens after 40 meals?
Runs out of money.
He runs out of money. So he can get 40 meals. This is kind of a big deal when you're in college. Okay, and you're eating at the cafeteria. I know mom and dad pay for it now, but in college that's not always the case. So 40 meals, you got to know how many meals you have. You walk in there someday and you're hungry and you don't have more meals. It's kind of a pain. All right. So that's the answer. Is 40 meals is where he stops. He's done. Okay. All right. Your assignment. Page 154, numbers, and I'll give you tomorrow to work on it. Okay? Page 154, thank you, Ashley. 10 through 32. I want you to see how she initiated that. That is awesome. The more you initiate, the better it is for you. Okay, 154, 10 through 32. Due Wednesday.